Page 16, we're going to be graphing quadratic functions in three different forms. The first is vertex form, which is f of x equals a parenthesis x minus h all squared plus k. The second is intercept form, which is f of x is equal to a parenthesis x minus p parenthesis x minus q. And the last is the one that you're used to, is standard form, which is f of x is equal to ax squared plus bx plus c. When I put this into my notebook, I didn't do it until the very end, so I finished the back side first. Well, not the very first. I did the notes on the inside first, and then I did the back side for extra practice. And you'll notice that I've stapled it here. So after you're done with this, I wouldn't paste it into your notebook. You can if you want, but then you can't see examples 4, 5, and 6. So I just stapled the left side only. Alright, so the first form that we're going to look at is vertex form. It's f of x equals a parenthesis x minus h squared plus k. You'll notice this is actually very similar to the one that we would have seen as if this was transformed. And the only difference is where they have an h, we had a c, and where they have a k, we had a d. But aside from that, you can actually see your transformations, whether it moved up, down, left, right, or vertically stretched, compressed, or reflected. And so I wrote that in the notes here that you could in this form you can see your transformations. For a, it opens up if you a is positive, which means that a is bigger than 0. And it opens down if a is negative, which means that a is less than 0. And this is true because we know that this a is going to reflect it over the x-axis. So that would make sense that it would open up versus open down with the negative in there. Your axis of symmetry is going to be how much it moves left or right. Typically, your parabola starts at at y equals x squared. That's your parent function. It starts at the origin 0, 0. So this x minus h is actually going to move it either left or right. And so it'll be h units, which means the vertex will also move left or right, h units, and that's going to move your axis of symmetry as well. And so the formula for that is x equals h. Same thing with the vertex. With your transformations, the k is going to move it up and down, and so the vertex is normally at 0, 0. So if you move it left or right, h units, that'll be the new x value for your vertex. And if you move it up and down k units, that'll be the new y value. So your vertex is h comma k. So the first example we want to graph is f of x is equal to 2 quantity x minus 4 squared minus 3. In this case, the graph opens up since a is positive 2. The vertex, I can see that the original parent function moved to the right 4 units and down 3 units. So therefore the vertex is 4, negative 3. And you can see that with your h, which is in this case is 4, and your k, which is negative 3 in this case. When I go to graph this, I'll start with my vertex. So I'll graph a point at 4, negative 3. From there, I'll go ahead and plug in a couple of points, but I want to make sure they're near the vertex. So since the vertex is at x equals 4, I'm going to plug in 5 and 6. You don't want to go too far away from it because this square is going to make that number pretty large, which means it may take it off the graph. So when I plug in x equals 5, that's going to be 5 minus 4 squared, which is 1. Square that, that's also, well, squared is 1. Times that by 2 is 2, and then subtract 3, you get negative 1. So now I'm going to plot 5, negative 1. Using this axis of symmetry at x equals 4, I'm actually going to reflect that over the line x equals 4 to get me a new point of 3, negative 1 as well. And then for if x equals 6, you would plug it in as well. When you do that, you get 5. And so I'm going to plot 6, 5. And same thing, I'm going to use the line of symmetry, which is x equals 4, or flip it over, and you'll get a new point, which is 2, 6. You'll connect those points, and then this is the graph of your equation. The second form that we'll look at is intercept form. This is called intercept form because you can see the x-intercepts right away. Those are going to be your p's and q's. As far as a goes, it's still your vertical stretch and compression, but it also makes your reflection happen as well. So it's still going to be opening up if a is bigger than 0, and it's going to open down if a is less than 0. Your x-intercepts are going to be p and q. Notice this is x minus p and x minus q. So if you have a plus symbol here, that means your p must have been negative. Or if you have a plus symbol on the right side, then that means your q must have been negative. To find the y-intercept, it says to multiply a times p times q. So mathematically, to see that, please remember that to find a y-intercept, you let x equal to 0. So let's see where they came up with that. So if you plug in 0 into the intercept form, you get y is equal to a, parentheses 0 minus p, times parentheses 0 minus q. Well, 0 minus p is negative p, 0 minus q is negative q, and those two negatives will multiply together to give you p times q. And you had a from the very beginning from your vertical stretch or compression. So your y-intercept is a times p times q. You don't have to memorize this formula. Just remember from Algebra 1 that if you want to find a y-intercept, you let x equal to 0, you plug it in, and then you would be able to solve using the same concept. As far as the vertex goes, because we have a line of symmetry at the vertex, once you find your x-intercepts, if you simply find the middle point between the two, then you are going to find your x value of your vertex. So that's one way to find your vertex if you like, and then you plug that back into the original to find the y value. But because you have 2 points on a horizontal line, if you're using your x-intercepts, then you're doing the same thing as finding the midpoint between those 2 points. So you can take the two x-intercepts, p and q, and add them, and then divide by 2. That would also give you the x value of your vertex. So the example we're going to do is f of x equals negative 2, parentheses x minus 3, parentheses x plus 1. In this case, the graph opens down since a is negative 2. The x-intercepts are going to be 3 and negative 1, because again, notice that became x plus 1, so it must have been x minus negative 1, which means your q is negative 1. And then your p is going to be 3, so those are your two x-intercepts. The y-intercept, you can either plug in 0 into the original, so we would have 0 minus 3 and 0 plus 1. You would multiply that by negative 2, and if you do that, you get 6. Notice that is the same thing as multiplying a times p times q as well. You would get the same value, and that's what they told you in the notes above. Alright, we'll start with the x-intercepts. At x equals 3, you'll put a dot there, and then at x equals negative 1 as well. And then from here, what I did is I went directly in between the two, so the halfway point between positive 3 and negative 1 is x equals 1. So that's going to be my line of symmetry, which means that's going to be where your vertex is as well. So you take that x equals 1, you'll plug it back into the original, which is what I did down here. And when you do that, you get negative 2, parentheses 1 minus 3, parentheses 1 plus 1. You'll evaluate both of those parentheses using PEMDAS. And when you do that, you get 8. And so finally, your vertex is at 1, 8. So you now know where your vertex is. You already have your y-intercept, and you can take this y-intercept and simply reflect it along the line x equals 1. And so there's your full parabola with 5 points. And the last form that you're used to from your Algebra 1 days is f of x is equal to ax squared plus bx plus c. So looking at this top portion here, same thing is true. If a is bigger than 0, it opens up. A is less than 0, it opens down. And by the way, in each of these forms, this a that we keep talking about, which is your vertical stretch or compression, it's the same for every single one of them. So whether you're in vertex form or intercept form or standard form, the a will be the same for each of them. That's the only letter that remains the same. The axis of symmetry, you may remember, it's x equals negative b over 2a. That's going to be finding your vertical line where it cuts the parabola in half. The coordinates of the vertex, you would take that negative b over 2a. That would be the x value of your vertex. This f of negative b over 2a means take it and plug it back into the original where you see an x. You'll plug in negative b over 2a instead. And so once you evaluated that y value for that value of x equals negative b over 2a, you would get a y value there, and that would be your vertex by putting it together with those two pieces. Your x-intercepts, you should remember the quadratic formula. It's going to be at negative b plus or minus the square root of b squared minus 4ac all over 2a. And you would just simply use the letters up here, a, b, and c, to find that. And then finally, the y-intercept is going to be at 0, c. So if you plug in x equals 0 for each of these, c would be the constant that you would be left with. And then for a note, it just says that your x-intercept can also be found by factoring as well. So right here where you have your x-intercepts using this quadratic formula, in the case the trinomial can be factored using the factoring techniques that we learned on a previous page, you could find your x-intercepts that way. We actually did that already. We practiced some of those. Now our example for this one is going to be f of x is equal to 1/2 divided by x squared. I'm sorry, I said that wrong. F of x is equal to 1/2 x squared minus 2x plus 5. This graph is going to open up since a is 1/2, your b is negative 2, and your c is 5. Your vertex is going to be at x equals negative b over 2a for the x value of that. So I'm going to start here with the axis of symmetry to evaluate. B in this case is negative 2, so I'm going to put an extra negative out in front, divided by 2a, which is 1/2. the bottom here is 2 times 1/2, which is 1. And then these two negatives will cancel out to make it positive 2, and 2 divided by 1 is 2. So I apologize, I did make a mistake here. Your axis symmetry should actually be at x equals 2 instead. You would take this x value, you would plug it back into the original. There would actually be a 2 here, a 2 here, and a 2 here. So we're evaluating f of 2 to find the y value of the vertex. So 2 squared following PEMDAS is going to be 4. Multiply that by 1/2, that's going to be 2. Here we've got 2 times 2, which is 4. So that's going to be 2 minus 4, which is negative 2. And then negative 2 plus 5 is going to be 3. So your vertex should actually be at 2, 3. And so I should have plotted that here at x equals 2 and then y equals 3. So that's my fault, I apologize. And then your y-intercept is going to be when you plug in x equals 0. If you plug that in, these first two x's will go away and your constant is just going to be c equals 5. So 0, 5 is going to be your y-intercept. And you could take that and you can reflect it over the line x equals 2, the axis of symmetry. And you would have another point, I think here at 4, 5. Yep, at 4, 5. You would connect those 3 dots, and then that would be how you would plot this one. What I'd like you to do is to turn this over to the other side, the back side of this, and you are going to practice 3 of these. You have 1 of each to try, and so you'll do those that are on the back of your foldable. And once you're done, you'll use either Desmos or my answer key here to check your answers. Okay.